Hello everyone, today we will be focusing on our first practice problem for queues by building an array-based queue, and without any further hesitation, let's get started. And now let's go over our practice problem. So our practice problem states that we need to implement a queue using an array and then a linked list and perform the following operations. First, we need to enqueue, which is also indicated as a push. We need to enqueue an element to the queue. We need to dequeue an element from the queue. And we need to check at the front element of the queue, which in of itself is another variation similar to the context of a stack with push, pop, and peek, except for it's enqueue, dequeue, and front element. These are the three components that we will do, and the structure of the queue is different. For it goes first in, first out. Stacks go last in, first out. Stacks equal LIFO, queues equal FIFO. And finally, we need to check if the queue is empty. So first thing we're going to do is that we are going to build our queue from an array. Let me just move this over here. Here we go, and feel free to code along as well. Let me just put this right here for our requirements. All right. First thing that we will always do is that we are going to include our libraries, which means that we're going to include iOS Stream. And you can also do this on Visual Studio Code as well, or any other text editor, and then we'll use using name space std. Then I'm going to make a class called queue, and don't forget our int main function as well. Our class queue is going to have the following: int front rear size. Since we're going to be dealing with an array, so array queue. Array-based queue. There we go. Then I'm going to put in a max, which will be a static constant integer of max size equal to 3. We're just going to put in 3 different elements on the inside, and I'm going to fill up the array with our max size. What do I have this here? Oh yeah, that's right. Here we go. Now next part, I'm going to have a public instance. And I'm going to first initialize a function that we have. We have queue front. We're going to initialize the front, rear, and size. But the way how we're going to do that is we are going to put in 0. Rear is going to be -1. And the size is just going to be 0. For we have an array, and arrays always start with 0, which is why we have a rear at -1. Our front, since there's nothing already in, it's going to be at the 0 index, and our size is also going to be at the 0 index as well. So this is how we first initialize our queue array, or our array-based queue. There we go. Now the first part, I'm going to put in the functions enqueue, dequeue, check front element, check is empty. And I'm also going to have a function to print out results. So enqueue is going to be the following. We're going to have a boolean first for enqueue. And we are going to put it in our integer value, since we have an array based in integers, as indicated right over here, and our max size here. And we will check if the size is greater than or equal to the max size. That means we cannot add any more, and we're going to have a stack overflow, but I'm going to call this a queue overflow in this case, just for indication. Always check for edge cases as well. That's always the first instinct that we have in mind. And L. And then we will return false because we are dealing with a queue. And otherwise, if the size is greater than or equal to the max size, we return false. We return false. But if not, that means we are going to add in an element inside of our queue. And queues operate in, first out, which means we're going to go to the rear at the very beginning of it. And what we will do is that we are going to put in one element forward based on the max size with respect to it, array rear equals x, and we're going to increment the size as so and return true, indicating that we have already added an element on the inside. Now this is just one technique that we can do. There are different techniques that we can also go through as well. But we're just focusing on the different variations between front, rear, and size in respect to all of the different components of the queue. Now, the next part we're going to be doing is a DQ. Now I'm going to put an int DQ in this. And if the size is less than or equal to 0, we're going to count the queue underflow, because it's saying, hey, there's nothing in there. These series of techniques are very similar to what we did in stacks before in the previous video, if you happen to catch on as well, just for further context. And we will return 0 since we have an integer in this case. And if the size is within the range and not less than 0, that means that there's an element that we can get rid of. So int x equals array at the front, because in order to DQ, we always go for the element in the very beginning because of first in, first out. And that means the front is going to be equal to the front plus 1 with respect to the max size, similar to what we did over here, except for the difference is that we're kind of doing the opposite. And we also need to make sure that we spell everything correctly. And size will be decremented. And then we're going to return x. So that's how we do DQ. And now we need to check the front element, which is also known as a peak in stacks. So in order to check the front element, we're going to do int front element. This is how we're just going to call it. And if the size is less than or equal to 0, we can say Q is empty and L, and we're going to return 0. Otherwise, we will return the front of the array, because that is what we're looking for. So we always go with our edge case first, and then we're returning the actual front. And we return 0, kind of like in similar context of what we have for our Boolean as well, where there's true and false, except for we have integers in that case. Alright. And then the next part, we're going to check to see if it's empty. So we're going to do a Boolean condition is empty. And that means there are no elements whatsoever. And technically, Booleans are already set to true. So all we got to do is that we need to return true if the size is equal to 0 indefinitely. It is indefinitely equal to 0, hence the double equals right over here. Now, I'm going to create a function to be able to actually print out everything, and I'll also make this to calm this down. I'm going to call this function void display, and I can call upon within the whole queue class that we have. And this void display is going to have if the element is, or if the queue is empty, we can just say the following: queue is empty. Empty, sorry, frowny face. There we go. And then otherwise, we don't need the else statement for the sake of time, but you can. But to make things efficient, you can just put in the for loop, just save on time, for int I, because what we'll be doing is that we are actually printing out all of the elements in our array that we've made for our queue. So that means we will use a for loop to scan throughout the rest of the array. So we'll have a for int I is equal to front, I less than or equal to rear, and that means we're going to decrement through the rest of the loop as well. So we go plus plus I, because we are doing first in, first out, starting directly all the way from the front and then incrementing accordingly until we get to the rear because of first in, first out. And we treat everything accordingly between respect to the front and the rear. And that means we will output count array index of I to be here for each step and component. There we go. And now let's test this bad boy out. So first thing I'm going to do, I'm going to have an instance of queue, call it queue. Then I'm going to do a queue dot, well, let's look for the function that we did. And it looks like we need to put enqueue right here. I'm going to put 10. And enqueue always means pushing element. And let's go 20 and 30 because our max size is 3 that we've already stated. And then I'm going to do a queue dot display to test everything out, make sure that we have our whole queue. Then I'm going to output queue dequeue since we need to pop an element, and then element has been popped. I'm just gonna put this right here. Yeah, there we go. And then we're gonna call upon the front element, check out the front element, which means this is the front element, queue dot front element, call upon that function, and then we'll end that line, and then count finally updated elements in the queue. Queue dot display is indicated, and since we have an integer, we would have to return 0 as a base edge case. And I don't see any errors whatsoever. Let me just zoom out of here so you folks actually see what we're dealing with. Notice how we have our class queue, public, enqueue, dequeue, front element as indicated based on the problem. And we also have queue is empty, and then we have a function to be able to display everything. So now let's run this. And there we go. So we have 10, 20, and 30 as our queue right here. Then the next part is that 10 has been popped already. Because one, this isn't a continuous display that we have here, so technically that would be, if I just put dash n right here, and we run this thing, should be able to separate. There we go. 10, 20, 30, and then we already have 10 element has been popped, or sorry, has been popped slash dequeued. We can do that again. Yep, element has been popped slash dequeued. This is the front element, which is 20, right here, and then the update elements in the queue include 20 and 30. Right here, because we have the slash n already set up in place. And finally, we already did everything. So this is the array component. This is an array-based queue. And so, yes, I will put this in the comment section. Feel free to take a good look. Let me zoom out of it entirely. Let's got this in 4K, so there we go. There we go. Feel free to take your time. And now let's focus on developing a queue using a linked list. Hey everyone, thank you very much for taking time to watch this video. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions as well, feel free to put it in the comment section. And as always, take care. Cheers. Bye-bye.